So we're going to finish off this lesson 10.1, learning about sum and difference of functions. So for example 4, you're given the equations for f and g, and you want to find h, which is f minus g at x. And so remember that means f at x minus g at x. And when you're subtracting, the order absolutely matters. So f at x is the absolute value of x minus all of g. So again, it's like it's in brackets. And when you remove the brackets, all the signs change. And so there's that equation. You're given the graphs of f and g, and you're asked to sketch h at x on the same coordinates. So we saw yesterday this can be done by taking x values, taking the y value for each graph at that x value, and performing the same operation, which again in this case is subtraction, and it's f in front of g. So we need to use some points here that we can see on the graph. So the first one we could probably do is -3. So we're going to go f at -3 minus g at -3. And so using the points on the graph, f at -3 is 3, minus g at -3 is -8. Minus minus becomes plus positive, so that will be 11, which we don't have room for on our graph. So let's skip to the next point, which would be -2. So it'll be f at -2 minus g at -2. So f at -2 is +2, minus g at -2, which is -7. Again, minus minus becomes plus positive, so that'll be +9. So we can kind of guesstimate where that point will be. Right? So let's do h at -1 by taking f at -1 and subtracting g at -1. F at -1 is 1. G at -1 is -6. So that'll become +7. -1, 7. H at 0 will be f at 0. Take away g at 0, which will be 0 minus -5 becomes +5. So those first 3 points line up. Let's see if that pattern continues by finding h at 1. F at 1 is 1, minus g at 1 is -4. So that also is 5. So now that pattern has changed. H at 2 would be f at 2 minus g at 2. F at 2 is 2, minus g at 2 is -3, and that is also 5. And that pattern will continue because f is changing at a constant rate here, and g is also changing at a constant rate. F is increasing at a constant rate, and so is g. So the difference between those two values will be a constant. So this one actually looks like two separate lines. You're going to have one arm like that, and the other arm like that. And the next part asks us to state the domain and range. Well, there are no restrictions on x, so our domain will be all real numbers. We'll go from negative infinity to positive infinity. But we can see the range does have restrictions. As the graph goes to the left, it's going to continue rising forever. But as it goes to the right, it's going to stay flat. This graph has a minimum value of positive 5, and it goes upwards forever. So our range would be from 5 to positive infinity. So part D says, is f minus g at x equal to g minus f at x? So we already know that f minus g at x, we wrote that above. It's the root of x take away x plus 5. Now what about g minus f at x? So that'll be x minus 5 take away the absolute value of x, or the negative absolute value of x plus x minus 5. If we compare those two equations, they're obviously not the same. But if we look at it, we can see that the signs are all the opposite. If we take out a common factor of negative 1 out of this, it'll become the positive absolute value of x minus x plus 5, which what's inside that square bracket is equal to f minus g at x. The only difference is you got the negative 1 in front. That's like an a value of negative 1, which remember means that the graph reflects over the x-axis. So g minus f at x compared to f minus g at x, these two graphs are related. They are reflections about the x-axis. I guess we should say a reflection about the x-axis. Because if you take g minus f and compare it to f minus g, we see that they are exact opposites. If we take a common factor of negative 1 out of the g minus f, inside the bracket you get exactly f minus g. With the negative 1 in front, that's an a value of negative 1, which means the graph is reflected over the x-axis. Reach for the Top is an academic challenge program offered to students across Canada. Suppose the cost of t-shirts for the program includes $125 in fixed costs, $7.50 per t-shirt. The shirts are then sold for $12 each. We want to write a cost function and a revenue function. So our cost function, C at N, there's $125 in fixed costs. That'd be like for a setup fee. And then the company charges $7.50 per t-shirt that they make. So if we let N equal the number of t-shirts, it'll be 125 plus 750 N. The revenue function is what they take in. And those t-shirts are sold for $12. So that would be 12N. Again, where N is the number of t-shirts. So there's our cost function and our revenue function. We're asked to graph both of these and then talk about what the point of intersection represents. So we have our graph is set up there for us, partially because it's got our scales, but it's not labeled. The independent variable always goes along the x-axis. So that'll be N, the number of shirts. And then we're going to have the dollars on the y-axis. That's the dependent variable. So our cost one starts at 125 and goes up by 750 for every value of n. So we can kind of guess where 125 is. That's our y-intercept. But it's difficult to apply a slope of 750, rise 750 and run 1. Our scale doesn't really allow us to do that. So that's okay. Let's choose some different values of n, plug them into the equation to find out what c is. For example, what if n is 20? The cost would be 125 plus 7.5 times 20. That's $275. When 20 shirts are ordered, the cost is going to be $275. So we can put that point on there. 20 comma 275 is right there. Let's do 30. Let's change the 20 to 30. So if 30 shirts are ordered, the cost is $350. So 30 comma 350. Let's do one more. Let's do 10. When n is 10, the cost is 200. So those are nice points that we can put on our graph. We don't have to estimate where any of those are. And so here's our cost graph. And now we need to do our revenue graph. That line has a y-intercept of 0 and a slope of 12. So again, it's hard to rise 12 and run 1, but we could rise 120 and run 10 and kind of guess where that would be to do that. Or we can do what we did before, just choose some values of n. So when n is 10, again, that will be our dollar value of 120. When n is 20, 12 times 20 is 240. When n is 30, 12 times 30 is 360. So our graph will go through those points. And we did a pretty good of estimating those points because they all seem to line up fairly good. And the point of intersection, what it represents when the cost and the revenue are equal. The number of shirts so that cost equals revenue. After that point, they would be making money. Before that point, they would be losing money because their costs are higher than their revenue. But after that point, the revenue line is higher than the cost line, so they are making money. So the point of intersection represents the break-even point. That's what the point of intersection represents. And it doesn't ask us to find out what that is, but we could definitely do it using a calculator. Put the two equations in there, find the point of intersection. But it actually doesn't ask us to do that. So C says the profit is the difference between revenue and cost. Write our profit function. So profit is revenue, which is 12n, minus cost, which is 125 plus 750n. So again, the minus sign in front changes all the signs inside. And then 12n take away 7.5n is 4.5n. And so there is our profit function in terms of n, the number of shirts. Part D, identify the domain for the cost, revenue, and profit function in the context of this problem. Well, the domain would be that you can't have anything less than 0 shirts. You can't make less than 0 shirts, you can't sell less than 0 shirts, and you can't have a profit based on 0 shirts. So part D, the domain for the context of this question would be from 0 to positive infinity. 0 could be included, the positive infinity not. Okay? Math Kangaroo is an international mathematics competition that is held in over 40 countries, including Canada. Suppose the cost of prepping booklets for the Canadian version includes $675 in fixed costs and $350 per booklet. The booklets are then sold for $30 each. So we want to write an equation to represent the cost as a function of a number of booklets n, the revenue also as a function of the number of books n, and same with the profit. So our cost function, C at n, there's a fixed cost of $675 plus $350 or 3.5n. Our revenue function, the booklets are sold for $30 each, so that would just be 30n. And our profit function is revenue minus cost. And again, all of the cost function is subtracted. So it's in brackets. That changes all the signs inside. And then we can collect the ends together. Then part B says to graph the cost, revenue, and profit functions all on the same grid. So our cost function is 675 plus 3.5n. That has a y-intercept of 675, approximately right there, and a slope of 3.5, which is hard to do, so like we did before, let's use our calculator. We'll just choose some different values of n. Let's say the first one is 20. So that the point 20 comma 745. Approximately there. Let's let n equal 40. So we'll change the 20 to a 40, and we get 815. So 40 comma 815, approximately there. So there's the graph for the cost function. Our revenue function is just 30n. That has a y-intercept of 0 and a slope of 30. So when n is 20, 30 times 20 is 600. When n is 40, 30 times 40 is 1200. So there's those 3 points. And then finally, we'll do our profit function. which actually has a y-intercept of negative 675 and a slope of 26.5. So again, let's choose some points, some random values of n to get more points on this graph. The first one I'll do is n is 20. So 26.5 times 20 minus 675, that's negative 145. 20 comma negative 145. Approximately right there. Next, I will let n equal 40. So 40 comma 385, just below 400. Let's do one more. Let's do 60. 915. 60 comma 915, just above 900. Right? So there's that graph. How many booklets must be sold to make a profit? Well, there's two ways you could get that. The profit has to be greater than or equal to 0, or greater than 0, which would be the x-intercept of this graph. So one point we could look at would be the x-intercept of the profit graph. So it's just slightly more than, looks like, 25 booklets. Or you could also find where cost and revenue intersect. They are the same point. They're the same point. The same x value. So again, we could do this by putting all three equations in there. The first one is 675 plus 3.5x. The second one is just 30x. And the last one is 26.5x. Take away 675. The grid that we have here kind of tells us what our window should be. I'm going to go from negative 10 on the x-axis up to 70 with a scale of 10. I'm going to go negative 800 on the y-axis up to 1200, and let's put our scale at 400 on the y-axis. So again, the graph that we have, that we put our lines on, really tells us what our scales need to be in our calculator. So we'll graph them, and there's all three lines. And like I said, you can find the point of intersection between the first two lines. Second function trace, number 5 for intersect, enter, enter. So those are the right two lines, and then enter. And we get 25.47, which, as we said, it had to be something a little bit higher than 25. And because n in this case refers to the number of t-shirts, that has to belong to the set of whole numbers. You'd have to round that up to 26. Right? But our point of intersection is the point 25.47, comma 764. Which once again, we have to round the n value up to 26. But that should be the same number for the x-intercept of the third graph. So second function trace, we want the 0, which is number 2, and we have to move down to that line. There we go. Now we're on that line. The left boundary has to be somewhere to the left of the x-intercept, so that's good. The right boundary has to be somewhere to the right of the x-intercept. Good. And then hit enter, and you get exactly the same value for x, 25.47. So either find the point of intersection of the first two lines, our cost and profit lines, cost and revenue lines, or the x-intercept or the zero of the profit line. So 26 booklets need to be sold. To make a profit. And once again, the domain, same as the last one, and the number of booklets has to be greater than or equal to 0. Now, we probably shouldn't use interval notation, and we shouldn't have on the last one either, because that tells us that it's continuous data, which means that it belongs to the set of real numbers. So we probably should say all values of n such that n is greater than or equal to 0, and n is an element of the whole numbers. Because it can't be fractions or decimals. And if you use interval notation, you're saying it's continuous data. You're saying that those values belong to the set of reals. So we should fix this last one as well, because that's not entirely correct. And once again would have to belong to the set of whole numbers. You can't have part of a t-shirt. Okay? So in the booklet, you'll see a 10.1 assignment. Starts on page 11. Page 11, 12, 13, those 3 pages. Or no, sorry, 14 as well. So those 4 pages is what you should be working on for practice. I will post the solutions to Google Classroom so that you can check your answers. Okay?